Hello. Today we will be looking at a pull request I've been working on since May, sometime like that. It's intended to provide the search engine with better support for full text search. Previously, the search engine was using Bloom filters to encode the keyword positions, but even though this is a very fast way of intersecting and finding overlapping positions, it's not really accurate enough to do a lot of the stuff you expect from a search engine, like offer quoted search queries and so on. And so the text box solution is to encode the keyword positions using something like Elias gamma coding or something like that. Variable bit encoding of position deltas, basically. And this is something that's actually been implemented. It's not in production yet, but it's in the pipe. But the problem is that the index grows by like 70 gigabytes per partition, and there are 9 partitions, so that's almost more than half a terabyte. So it would be desirable to try to recoup some of that lost disk space. And before we get into this, some very basic search engine theory. Most search engines operate based on an inverted index. That is, at least most classical search engines do, and these are basically a mapping from keywords to a list of documents, and they are often implemented using B trees or skip lists. And the caveat is that the data doesn't fit in RAM unless you have like dozens of terabytes of RAM, but that's usually not the case. So the way you construct an inverted index is that you construct smaller indexes and then you recursively merge them until you have the big index. And this is the code we're going to be working in today, so that's why I am covering this. And the Marginalia search engine actually uses 2 inverted indices, and the reason for this is that it's desirable to ensure that documents that are strongly relevant to a particular keyword are considered early, because there are cases when the computation time takes too long and then we abort after some time points, and if the most relevant documents haven't been processed yet, then we're going to be returning bad results. So using relevant signals such as TF-IDF or whether the keyword appears in the title or something like that, the search engine puts certain keywords and documents in a separate index that can be scanned first, and this is smaller than the full index, but it doesn't actually need like keyword metadata or a positions listing. We can keep that in the full index and just consult that when we need that data. The priority index, strictly speaking, only needs to be a list of documents. So that is where we're heading, and this is from a test run I did on the old production server, which is now a test environment. And we can see that the change has created a new file called rev positions, which is 70 gigabytes. But it also added a new file called rev prior positions, which is not something we want, and we don't want the positions listing for the priority index. And the documents file for the priority index is also unnecessarily large because it's storing like pointer offsets into this positions file. So we should be able to actually reduce the size of the index by 60 gigabytes compared to what's in production, which is very nice, instead of increasing it by 70. So as mentioned, the priority index as well as the full index, it interleaves the document ID with a pointer into the positions file. And for the priority index, we obviously don't need this. So we can just have a list of document IDs instead. And after this is done, maybe we can think about compressing this somehow. But this is already a pretty large change, and there's a lot of essential complexity and general finickiness. So we will try. All right, so let's get to it. This is the package we will be working in. It's called index reverse. It's not called inverted index. Maybe it should be. On the other hand, there's a benefit to not having it called inverted index, because it's easier to distinguish between the concept of an inverted index and this particular implementation. So that's where we're at. This is the code that deals with constructing the index, both the full index and the priority index in the current version of the code. I think the plan will be to basically duplicate and fork this implementation. There's an argument to be made for having it supporting both versions of the index, but I think that's a bad idea, because I expect it will be diverging more in the future. So even though the initial implementation will be very similar, we might end up doing this fork anyway, and that's only going to be nastier if we already made changes to it. And even though, I mean, the code duplication might be a bad thing, but this is not going to be duplicated more than once. So in that scenario, you generally should tolerate it, I think. I think the first step will just be to change this prefix to full. Actually, we should create a package first that's full. And then we have a package that's prior. Actually, should be spelling it correctly. Like so. And then we move these guys into full. And IntelliJ has discovered 8 invisible conflicts. It's interesting. Find an open window. Yeah, it's just some tests and a crash log, so that's fine. You do that. The tests will be failing for quite some while anyway, so we can keep going. And this is the positions file constructor, and it doesn't need to be in the full part. And these guys are also agnostic. Right. So what's the best order of doing this then? We should be renaming these, I think. Sure. Sure. Like so, and now we have some problems with the tests because these guys expect to be in the same package. Are these guys happy now? We can pull all these guys in here. This is very far from TDD, so we're not going to be worrying about the tests too much right now. There's a time for that. Let's see what we have changed now to ensure that the refactoring logic hasn't messed anything up. Sometimes it's refactoring things you don't want to change, but I think this is fine. Now we need to copy this floppy over here. Actually, let's not do this yet. I think that's only going to be causing problems. So yes, we're just creating new versions of this code so that we can modify it. The tree transformer. I wonder what happens if we do this. Just search and replace. And it's only in this directory. Let's see. That's certainly a way of doing it. Do we have problems? Right. Some slight refactoring gore, but what are you complaining about? Have we done it? Let's see if the tests still run. I expect they might. Actually, this test isn't fixed yet, so it's expected to fail. That's fine. This branch I'm working on is still sort of slightly smoldering in some places from the change to the index. So there are a few tests that are a bit broken still, but maybe we will have time to fix them in the scope of this change. Can we just hook this in now? Like so. Now it's actually running the code, but the code is identical, so there's not actually all that much to be won from that. But actually, I think we can go to have a huge test case that actually runs through. Basically, the entire system from simulated crawl data to all these conversion steps and index construction and so on. And it's probably the best way of figuring out if a change like this is working. And there's an expected exception somewhere in here. Has to do with the fact that we haven't set up a database. But actually, this looks like it's working. So I think we will make a commit here. Just to get some sort of a working baseline for this refactoring, since we're in a working state. And this commit first line is too long, but we can edit that later. Right, and then we go back to the index scope. Right, so what do we actually need to change here? Positions file constructor should go away because we're not constructing a positions file for the priority index. So let's just remove that and see where that takes us. Move that. Now this guy isn't happy. Move that. Move that. Have some complaining down here. And we don't get an encoded offset. Current size longs should be 1. Then we can do that, and then we can do that. Right. It's getting easier. Quicksort n is. It's actually just doing the regular quicksort if it's getting record size 1, so that's fine. This quicksort method is doing a bunch of logic too. It's capable of sorting pairs of longs as well as just single longs, and it's also sometimes delegating to a C++ implementation. But that's not available for actually it's not delegating to the regular quicksort. Anyway, the C++ implementation is only available for 64 and 128-bit values and not larger. Yes, so we can actually just do this instead. No. Like so. Let's see what this is doing. It should probably not be called. One of these function names is wrong. Either it should be quick sort everywhere or sort everywhere. But that's not within the scope of this change. Right. Right. So within this class, I think the change should be relatively trivial. And this is the class that constructs the pre-indexes, which is this small part of an index that fits within RAM that it's later merged. And it's doing some stuff that maybe we want to look into later, but let's just try to get this working first. Let's see, where are we merging this? Right, merge. It would have been very nice if I had a constant for the record size in this guy as well, but I don't think I have. This is the finicky part. Let's see. Let's change this guy, this guy, this guy. Remove this guy. Right, and this is constructing the B tree from keyboard to document. So we want to retain these multiplications of 2 over here. This guy should be 1. Should be 1. This should be 1. This function is finalizing the indexes. It's creating a B tree for the data. The pre-index are just basically sorted segments of data without an actual B tree index. Right. I have no idea if this is going to be working. And this is sort of the nasty part of doing this sort of refactoring. It's hard to do it in a particularly structured way. And it doesn't feel good to be doing it like trial and error and just hammering at the code until it compiles and behaves as expected. But I don't know if there's a better way of doing it, to be honest. Looking for multiplications by 2. All right, and we also actually need to alter the reading part of the code before we can actually even begin to test this, which is not nice either. Let's see if we get some like exception when we run the code, at least. I fully expect the querying part will be exploding quite hard, but it's fine. No, it's actually working. That's unsettling. Right. Are we doing something in the test that makes this not valid? Just find out quickly. Priority, of course. This guy is not actually running the correct code, and that would explain why it isn't blowing up as expected. This integration test is pulling in large parts of the system and basically piecing it together into a single sequence of execution. But in some cases, it's necessary to basically copy some functionality from the system to make it work. Let's see. We weren't getting priority positions, at least that seems encouraging. But I'm still a bit confused as to why this isn't blowing up. Actually, that's fine, I think. Maybe it's not a problem. Yeah, let's not get lost in this test. It doesn't really say all that much yet. We will need to do this. This. Don't think we need to have a self-test function anymore. I was having some very deep and mysterious index corruption issues at some point and implemented some self-testing logic to help identify it. But I don't think we need it anymore. And this function finds the offset for the data corresponding to a single word, and that shouldn't change. This creates an entry source that lists the documents with that word ID, and this should actually change. We don't want this guy, we don't want this guy, we don't want this. Actually, maybe I want this guy. And this is needed. This should not be here. Because this priority index should be a very slimmed down and reduced version of the index that doesn't support retrieving keyword metadata and so on. But we need to actually butcher this entry source as well. Let's begin by doing this, and then we get priority entry source as well. And the priority entry source should not have these stagger aspect to it. And since the full index interlaces the document IDs with the offset pointers to the document positions file, there's a step when retrieving the documents ID where this is stripped out. But since this new file is not going to be interlacing the data, then we don't need that step. Precise 1. Could possibly have like a check for. Actually, yeah, we can keep this guy, I think. Let's do this, remove this guy. Because it's this guy has an entry size property, and if we set it to 1, then it's not doing the stagger. So that means we can just keep using this guy, which is very nice. Not want like pointless duplication of the code either. All right. Let's run this again, just for fun. Actually, it's not going to be working because we need to get in. Like so. And this guy has a positions file reader, and we don't need that guy. Because the priority index doesn't have a positions file. We were feeding it with null. Still. And this is. Let's just pull this in over here. Do we need also? This is in the index query construction logic. Actually, I think we can throw this guy out and only have have it do like this. It doesn't really make sense to require multiple priority terms, which is what this guy was doing. This is basically iterating over the keywords and creating variants of the query for searching first the full index, but also the priority index. And these are run in parallel, so the order doesn't really matter, but it's important that we do get both, but I don't think it's necessary to have require multiple priority terms. I don't think that adds anything other than wasted CPU cycles, that is. Possibly we should be tuning this more, but let's try to keep on mission for now. Are we compiling at this moment is a good question. No, we are not. Because we removed the position file reader without removing the close statement. Right. It would be nice to be able to test this at least a little bit. Is that possible? Maybe I should bring up like a test environment or something. Because this integration test doesn't appear to be covering it, and I would like to see something blow up, because something inevitably is going to be blowing up if you're doing something like this. So let's just build it and run it to see what happens. Could of course be that we just got incredibly lucky, but that's my intuition is that there's probably something that's broken somewhere. And the fact that we're not seeing anything blow up is an indication that something is wrong rather than something is correct. When you're doing like a simple basic change, I wouldn't expect crashes and bugs, but this is incredibly finicky, and we're like doing on disk pointer arithmetic without any guardrails at all, so it would be almost miraculous to have it like just working. Right, and we need to I do this. Yeah, the why are we getting this guy? Right, this is built on an old version of the code, so it doesn't have the positions file. That's expected because we need to go in and actually process some data. We can process my websites. This should be relatively quick, but let's see. All right, I've had some food and a moment to think about the changes we have made, and some things cropped up. As usual, thinking about coding has pretty good leverage. You usually discover stuff that you might not see when you're actually working with it. First of all, being this prior reverse index reader is not necessary in this index query builder input class, so let's just go ahead and drop that. It was used before, but now we aren't doing anything with it anymore, so let's just throw that away. And I also actually realized why this isn't working as expected. To test the code, I performed this query, and the need to add doesn't appear in this document. The problem is that the is a stop word. If we remove that, then it's matching. So there's some tuning that's still left to be done in the full text search as of things, but another shower realization I had was that I think there's a bunch of comments in this guys that mention reverse pre-index, I think at least. So let's find out. Well, at least one case of comments. And that's the documents class. Remove that guy. All right, so that's cleaning stuff up a tiny bit. And I think we can actually just amend this to the previous commit, as it's stuff that should have been done anyway. And next up on the chopping block, actually, this is where I wanted to go. I think I should be adding a test to the priority index. I wonder what's a good place to put this. These tests are super complicated because you need to basically make assertions on the arrangement of data on disk, so it's really finicky. Can we do this in some way? I think we want to base it off this test case, and then we just hack at it until it does something that's similar to what we want it to do. No, I don't want to create a file. I want to create a package. So, and then we just copy it over here. And then it's complaining. Why is it complaining? Create reader. Test journal factory. Should be public. It might be happier. And right. Right. What are we doing over here? Just throw this stuff away. So maybe it's this full print next document. Let's do a reverse in here. No, that's not it. What's it called? Prior pre-index. Like so. And then we don't have this guy. So this will create a pre-index document. Is this what we want to do? Should we be basing it off the finalized? Yeah, maybe we should be basing it off this guy instead. Because we're not super interested in the documents aspect. I have some changes planned where this will be useful, but this is not the time to have this level of granularity. Unfortunately, some of these tests they're a bit too low level to be super useful. I built them when implementing this, but there's not really anything that ever changes. So just steal this guy. We can worry about where these tests go later. Prio index. This is wrong. Finalize. Now we have a words on the documents file. This. Maybe. And then this guy should be journal reader. So super duper clear. And what are we putting into this? Word ID is 50. And actually, this is an entry source. And then we need a long query buffer. Let's try doing this. See how badly it blows up. Right. So perhaps. No, actually that's correct. This is the document ID. 50 is the term ID. So this appears to be working. At least in this very super duper basic test scenario. Let's add another guy. Will this work? No, that's why it's wrong. Matching parentheses sometimes. 100, 104. This should be sorted. And this is a bit awkward to interact with. Oh, this is not what I wanted to do. This is a bit awkward to interact with. It's not, you're not intended to just grab the documents. There's a bunch of structures here to enable a very efficient way of intersecting result sets. So that's why we have this. Right, it actually blows up because this is not sorted. Why do we think it's not sorted? Transform each IO. Right there. Is there something wrong with the B tree? Oh, aha! Here we have a bug. Let's do this. I knew there was something messed up. So then we go and here we go and look at where this is being used. Why can't I edit this? So this is wrong. So bit curious why we didn't run into this when we were testing it earlier. Maybe it was accidentally sorted. Possibly. Yeah, that's actually a bit curious, but now we've actually found a bug that makes me a lot happier, because I was expecting something like that to crop up. That means we're on the right track. If you're testing stuff and not finding anything, that's usually a signal that you're testing the wrong thing. But this appears to be working. Actually, I'm very curious why we didn't run into this earlier. I think we should discard this guy. Just rename this to full pre-index test for now. Because there's the common scenario when this is failing, that it's failing quietly by not returning the correct data or not returning any data. And the way you discover the bug is that the search results aren't very good. But this appears to be like a construction error. And I would expect this to crop up in when running this in production as well. Let's just fail this and see what happens if we go to the integration test. I could add a breakpoint as well, but breakpoint makes the code run slower, so I'll do it the old-fashioned way. Right, so we do in fact run this code. very peculiar. It could be that it's not failing because there's only a single record. That would make sense. It doesn't really explain why it's not failing in the test. The test environment I set up. Let's try redo this just for fun. And the tricky part about testing is that you can usually only demonstrate that stuff doesn't work. Hard to prove that something is working. But having found some issue at least gives me confidence that we're on the right track. Finding no issues gives me the programmer ick. Right, let's see, is this starting up? Oh, we're in the create debugging tool now, but it's not fully working right now because I removed a bunch of parameters that should be exported. So there's a bunch of zeros over here. And that's to be fixed within the scope of the pull request, but not today. What were we searching for? I felt the need. Let's just do that.